So we've done all of this, right? We are familiar with the proof. We did the proof quite nicely. We did this fairly nicely also. We had some challenges here and we got into it and we understood that we had to use that in terms of that and then end up with an answer of 1 over sine 18. And then the last one is asking you, so it's all still part of the same question, right? So it says that if you have proven this identity equation, show that without a calculator that sine 18 degrees is a solution for the cubic equation 8k minus 4k plus 1 is equal to 0. Let's just take a step back. We don't need to know anything here about factorizing a cubic equation or the standard form, although it's kind of in the standard form already, because there's just a square, you know, that's missing. So the coefficient, if you look at the standard form, the coefficient of the square part is 0, so there's no square. In other words, ax cubed plus bx squared plus cx minus b or something, okay? But that's not what we're looking at here. We're not concerned with that. We still, yes?
Do they basically mean that this expression basically must be equal to sine 18? Because why do they say sine is a solution for the cubic equation?
Let's quickly explore what that means. What does this mean, is a solution? If something is a solution for this equation, it means that, remember this is an equation, it's equal to 0. So anything that's a solution for this means if you're going to substitute the value for k, it must make it equal to 0. Then it's a solution. If I put in 3 in here and this thing does not equate to 0, then 3 is not a solution. So that's what solution. So if they say we must show that sine 18 is a solution for this, it means that if you put in sine 18 into there, it must be 0. But it's not that easy. You're not going to take sine 18 and equate into the k and then, yeah, that's not what we're going to do. We still need to look at, and my clue here is to sort of speed this up. The solution to this problem lies with this one here.
Which one? 4 cos.
The one before that, yes.
So then 4 cos 36. Can a person like substitute say something into k?
If you take if you now before I start, because remember again, this is problem solving. So like I said, if you were faced with this question in the exam, there's a good chance that you would look at this and like, what the hell? You might not get it. Okay, that's just the reality, and it's not to say that there's anything wrong. It's just it's not everyone's going to get this. That's all I can say. But that's why I'm going to set you off on the right path here, because I want to expose you to this, so because it will help you, so that when you get to the exam, you are expecting things like this, little curveballs. Because this obviously has nothing to do with the stuff you did initially. This was quite easy and nice actually, but what the hell is this? Now, I'm going to say that to start off your solution, you're going to start off with what you had here. So here, your previous proof is going to serve as your starting point for the last one. I'm saying work with this. You need to work this, and you should see something. In other words, if I can get an expression, if I can get an equation in terms of sine 18 that looks like this, equal to 0, then I have proven that sine 18 is a solution, because if I can write an equation in terms of sine 18 where I have sine 18 to the power 3 minus 4 times sine 18 plus 1 is equal to 0, then it's like the sine 18 and the k is the same thing, which means I've proven what they asked me to do. And I'm saying this is where you need to start. Okay, let me start you off. Let's say that if I'm going to start manipulating this equation, I'm going to multiply both sides by sine 18 to get a fraction.
But so is it going to be like what's going to be a common factor then?
Don't worry.
Let's just see
3
what
times
happens.
sine 18
Let's see how many steps it's going to take for me. No, how many steps it's going to take for you to see what's going on. Where you're going to get your moment. Let's see how many steps it's going to take. So I'm going to multiply both sides with the sine 18. Is equal to 1. Right? That's my first step. I multiply both sides with sine 18.
We see
Anything?
it. We see
Anything?
It. We see
Why?
it. We see it.
No, we don't yet. Wacht.
As you multiply, I want like when you would normally get rid of a fraction, you multiply with the denominator through everything, so that you can get rid of the denominator fraction. So you multiply that with sine 18, so it became 1, and you multiply this also. That's
And we
what
carry
it
the 1 over.
Yeah.
Isn't that the...
Wait.
Like the first part is I whatever, and then the second sine 18 is like the fourth.
So now it's starting to take a little shape, a little bit. Maybe you see something happening.
Maybe. Yes.
Can we use a double angle?
Right.
Can we divide by 4?
That's sine 2a.
Can we take out the common 2
Where's the common here?
in the double in
More
the
than
angle?
common. Remember, you need to end up with something that's raised to the power 3 as well. You know? So how are you even going to get there? The expansion thing is that's the right way to go. But remember, they want you to prove that. Okay, let me circle this. They want you to prove that sine of 18 is a solution. So you want angles that say your angles must be. What must your angles be in your thing that you're working with now?
Sine 18.
It must be 18s, because that's what they want. They don't want other stuff there.
Oh,
Two
so
times
we must
2
make
times
the
18. What did you say?
yeah, we must make the 36 smaller. Not I mean like in terms of
Is that small enough? Right, so 4 chords of what? How am I going to write it?
218. Sine 18.
Pretty.
Okay. Now what?
And now what?
Fiora, you asked for something. Did you get it now?
Somebody come
Cos 2 theta is
a double.
So jy het 'n dubbel hoek, né? Nou my vraag is, jy het 3 opsies vir jou dubbel hoek van cos 2a. Watter een gaan vir jou pas?
Ooh, Afrikaans.
Nice Afrikaans.
So
now plus 1.
sine
Which one?
The way the 1 is positive.
1 minus 2 sine squared 8.
There we go. Now we're getting somewhere.
No.
So I'm going to use 1 minus 2 sine squared of 18. That's the one expansion. Times sine of 18. Minus 1 equal to 0. Now what?
You times the 4.
Into the bracket. So I've got 4 minus 8 sine squared 18.
Times sine.
Is that sure?
Okay,
Oh,
there's another
there's
sine.
the cube done.
Minus 1. And now, but we kind of give ourselves extra work here because the 4 and the sine 18 is outside the bracket, so I could have just multiplied 4 sine 18 into the bracket the first time.
Yeah.
Yeah?
Yeah, but it's just like.
But I can still, so I multiplied the 4 into the bracket now, right? Distributive property. But there's still a sine 18, so he must also be multiplied into the
Okay,
bracket.
that just. Yeah.
Yeah?
So just
That's
like-
why it's just a bit of a sloppy work here. We could have written the 4 sine 18 together on this side or that side and multiplied the whole thing the first time. But anyway, so that would be 4 sine 18 minus what?
8 sine cube 18 minus 1.
And now what? So now we're getting our moment.
But mustn't we rearrange it because the cube is then in the middle?
Okay,
I
so
see,
rearrange it.
Yeah.
So what was our
Negative 8 sine. Negative, yeah.
and then and minus 1.
Yeah.
Am I there yet?
Multiply.
Fine. 9 negative 1. Because that's not the form yet because my signs are a bit messed up. So if I multiply through by minus 1 or divide through by minus 1, I've got 8 sine cubed 18 degrees minus 4 sine of 18 plus 1 equals 0. And now I have the exact same form. So if you had to just rewrite this, that would be, so you can clearly see how sine 18 and k
Oh,
have the
yeah.
same position and function. So there's my k cubed, there's my k, and there's the rest. So therefore sine 18 is a
Solution.
solution.